A drone, flying low over open ground. No missile rises. No explosion. Just a beam of light, steady, silent. And seconds later, the drone falls out of the sky, burned through the side. This is Iron Beam. And as of this year, it's not a demonstration. It's a combat weapon, already in use. Most defense systems intercept by throwing something heavy at high speed. This one doesn't throw anything at all. Iron Dome does it with a $50,000 interceptor. Patriot does it by physically colliding with its target. Even Golden Dome, for all its complexity, is still fundamentally about putting mass in the path of a missile. Iron Beam breaks that pattern. It's a 100-kilowatt beam of focused light, and because light already moves as fast as anything can, there's no flight time to calculate, and no lead angle to solve against a maneuvering target. Aim it, hold it, and the engagement has effectively already started the instant the beam locks on. The real engineering challenge isn't aiming, it's staying. The beam has to hold a precise lock on a small, sometimes tumbling target for several continuous seconds, through real atmosphere, before that target actually fails. Here's what the system actually is. A 100-kilowatt class solid-state laser, mounted on a ground unit, built by Rafael and Elbit under Israel's Ministry of Defense. It went into service at the very end of last year, and in March of this year, it was used in actual combat for the first time, intercepting rockets and drones fired from Lebanon. It sits as a fifth layer inside Israel's existing defense architecture, alongside Iron Dome, David's Sling, and the Arrow family, built specifically to catch what those systems weren't designed for. Threats that are slow, low, cheap, and numerous. Effective range is reported at roughly 7 to 10 kilometers, shorter than Iron Dome's reach, and that's deliberate. This isn't meant to replace the missile layer, it's meant to sit inside it, catching the cheap, close-in threats before they ever force a $50,000 interceptor to fire at a target that costs a few $100s to build. Here's why any of this matters beyond the physics. A Tamir interceptor, Iron Dome's missile, costs around $50,000 every time it fires. A single Iron Beam engagement is reported to cost somewhere between $2 and $5. That's not a discount. That's close to 3 orders of magnitude. There's no missile body to build, no rocket motor, no guidance electronics, no warehouse of finished rounds that needs constant restocking. The ammunition is just the power grid the system is plugged into, and as long as that keeps running, in principle, the magazine never actually empties. In a fight where the other side is launching cheap, mass-produced drones, specifically to drain expensive interceptor stockpiles, a weapon whose marginal cost per shot is closer to a fast food meal than a small house changes the entire math of who can afford to keep defending. None of this makes Iron Beam invincible, or a replacement for everything that came before it. Light doesn't travel as cleanly through fog, dust, or heavy rain. And reporting on the system is candid that missiles remain the necessary backup on bad weather days. A reflective coating on a target's surface can buy it a little extra time under the beam, though even a surface reflecting 99% of the light still can't stop the remaining energy from eventually burning through. And no matter how powerful this class of laser gets, a ground-based beam can't reach a ballistic missile arcing through space at several kilometers a second. This is a close-in weapon, not a substitute for Arrow or Patriot, or the orbital architecture Golden Dome is trying to build. It solves one specific piece of the puzzle: cheap, slow, numerous threats that were quietly draining everyone's missile stockpiles. And it leaves the rest of the layered system to do what a laser still can't. Every system we covered so far has really been an argument about how to make one moving object hit another moving object. Better, cheaper, or from farther away. Iron Beam is the first one that skips that argument entirely. It doesn't throw anything. It doesn't collide with anything. It just holds a beam of light steady for a few seconds and lets physics finish the job. What happens next is mostly a question of power. Rafael and Lockheed Martin are already discussing systems 3 times as strong, and the US Navy already has a version of this at sea. Every doubling of power cuts the time this weapon needs roughly in half. We'll be watching to see how far that curve actually goes.